Assalamu alaikum. This is 12th chemistry, and our today's topic is this ring substitution reaction in case of these aromatic amines. Now, as far as these aromatic amines are concerned, these aromatic amines undergo these electrophilic substitution reactions more readily as compared to benzene. This is due to the presence of the amino group, that is the NH2 group in case of these aromatic amines, and this amino group acts as an electron donating group, or it is an activating group, and it relatively increases the electron density of the ring, especially at ortho and para positions. Now you can see here, now as a result of this, the incoming electrophile, it will be directed either towards the ortho or towards the para position. So we get ortho and para derivatives in case of these aromatic amines. Now you can see here, this is an amino group due to the presence of this lone pair of electrons. You can see here lone pair of electrons. This participates in the conjugation, and we see the electron density gets relatively increased at this ortho and para position. You see the electron it is then pushed to this carbon atom, and the negative charge moves to this carbon atom. Then it moves to this negative charge is pushed then to this, and this double bond is pushed to this carbon atom. We see negative charge over here. So we have got two ortho positions available and one para position. Now as far as this electrophilic substitution is concerned, the electrophilic substitution, this reaction in case of these aromatic amines, since it takes place more readily, so it is not possible to set up this substitution at mono substitution, because this and this NH2 group, since it is an activating group, it increases the electron density of the ring much, so the reaction becomes much faster, and the substitution does not stop at mono substitution. So in order to get these mono substituted derivatives, the activating effect of this NH2 group, it is to be reduced, so that we can get these mono substituted derivatives. You can see that this process, or this is done by means of acetylation. Now acetylation means by treating this aniline. You can see here, this is aniline, by treating it with either with any acid halide, say acid chloride or acid anhydride. Now you can see here, this hydrogen, it reacts with this Cl, and it forms this acid halide. Now the lone pair of this lone pair of electron on this nitrogen, instead of this participating in conjugation with this phenyl ring, it is involved in conjugation with this carbonyl carbon of this acetyl this group. Now you can see here, this electron pair, it is on nitrogen atom, it is pushed towards this carbon atom, and then this double bond is pushed to this, so negative charge moves to this oxygen atom, whereas positive charge gets developed over this nitrogen atom. So after acetylation, we can get these mono substituted derivatives. Now if this acetylation if acetylation is not carried out, or it is not done, then in that case we get di substituted products will be obtained. Now as far as this electrophilic substitution in case of aniline is concerned, we have got various types of these electrophilic substitution reactions. Like we have got this is halogenation. Now as far as halogenation is concerned, it is the process of replacement of one or more hydrogen atoms from this benzene nucleus in case of this aniline, and by halogen atoms is known as halogenation. Now halogenation, for example, in case of we subject it to bromination. Now in this reaction, we see this aniline, when it is treated with bromine water, we get a trihalo derivative. We get a 2,4,6 tribromo aniline. It forms a white precipitate. So when this aniline is treated with this bromine water, we get a white precipitate of 2, 4 and 6 tribromoaniline. Similarly, then we have got another this type of another this electrophilic substitution reaction, that is nitration. Now nitration, it is the process of this replacing the process of replacing one or more hydrogen atoms in aniline, in the benzene of this aniline by nitro group, that is called as nitration. Now as far as this nitration is concerned, this nitration is usually carried out using a concentrated using a mixture of concentrated nitric acid and concentrated sulfuric acid. Now we cannot carry out this nitration of this aniline, or the nitration of aniline cannot be carried out directly, because since nitric acid, it is a strong oxidizing agent, it decomposes this amine group. So before carrying out the nitration of this aniline, this NH2 group or the amine group has to be, first of all, it has to be protected, and this is done by means of acetylation, that is by treating it with acetyl chloride, or by treating it with acid anhydride, say ethanoic anhydride. Now you can see here, this is aniline. So when it is treated with this acetyl chloride, it forms acetanilide, or we also call it as N-phenyl ethanamide. This is a UPAC name. Now the acetyl after acetylation, the acetanilide that is obtained can be now easily nitrated using a mixture of this concentrated nitric acid and this concentrated sulfuric acid. You can see here, this is acetanilide, or it is N-phenyl ethanamide. So when it is treated with this mixture of concentrated nitric acid and concentrated sulfuric acid at a temperature of 288 Kelvin, we get O nitroacetanilide, and we get a mixture of O nitroacetanilide and P nitroacetanilide. Now the orthonitroacetanilide and paranitroacetanilides, these are then hydrolyzed in acidic medium to give the corresponding, that is O nitroaniline and paranitroaniline, with the formation of this two molecules of these acetic acid are also formed in this reaction. So this is how nitration is carried out, and how this amine group can be in aniline can be protected. Now then another reaction is, that is another this electrophilic substitution reaction, that is sulfonation. Now as far as this sulfonation reaction is concerned, this sulfonation reaction is usually carried out using a mix this concentrated sulfuric acid. Now in this reaction, in case of this sulfonation reaction, the product formed is anilinium. It is a quaternary ammonium salt, or we call it as anilinium hydrogen sulfate. Now this upon heating at a temperature of 450 to 470 Kelvin, it loses a molecule of water, and it rearranges itself to give this sulfoanic acid, or we can also it as para-amino benzene sulfonic acid. Now this sulfoanic acid, then it has got both this acidic as well as basic group, and it exists as a Zwett ion, and Zwett ion, and that is a dipolar ion. We see here, this is acidic group, that is NH3 group, and we have got this is basic group. So this Zwett, it is sulfoanic anilic acid, it exists as a Zwett ion or a dipolar ion. So this is how this electrophilic substitution reaction in case of aromatic amines is carried out. So this is for today. Thank you very much.